Okay, so welcome to calculations using significant figures. So before you attempt this sheet, make sure that you understand how to identify number of sig figs, and you are really comfortable with those rules. So this is when you're doing some math. So remember, significant figures come from measurements done in the lab. So calculating a volume, finding the mass. But then what if you took that mass and volume and divided them to get a density? What do you do then with that final answer? Especially if those two things that you divided had different numbers of sig figs. So here are the rules. When multiplying and dividing, limit and round to the least number of sig figs. So for example, this has 3, 3, 2. You would round this final answer to the 2 sig figs. Please don't misunderstand. Rounding to sig figs is not the same as magically changing the numbers. I am not saying that 190,000 is the same as 188,784. Those are not equivalent numbers, obviously. However, we are not able to round our final answer to this number of significant figures. This is 6 sig figs, and you are limited to the fewest. I don't know if you've ever heard the phrase, you're only as strong as your weakest link. So you're only as accurate as your least accurate measurement tool. So in multiplying and dividing only, that's the rule. Totally different rule when you add or subtract. Fewest number of decimal places. So not total sig figs. So instead of saying this has 5 sig figs, I say this has 2 decimal places. Instead of saying 3 sig figs, this is 1 decimal place. Instead of 5 sig figs, this is 3 decimal places. So add it up as you normally would, but round your answer to 1 decimal place. Okay? Why are those two rules different? Honestly, I don't know. Look it up and let me know. Teach me something, okay? All right, so the first thing I'm going to do is I'm going to do the math as normal, and then we'll round our answer to the proper sig figs, okay? So first one is 1.35 times 2.467. So my calculator gives me 3.33045. That is way too many sig figs. So because we're multiplying, I'll go back 3 sig figs, 4 sig figs. So which is less? Well, it's 3. So here are my 3 sig figs, 3.33. But remember, there's also rounding involved. So you always look to the one beyond. Is this 0 enough to round that 3 up? No, it's not. Remember the rule is 5 and up, round it up, or 5 and above, give it a shove, or whatever it is. So 3.33. Now our units. Meters times meters is meters squared. Okay, units are important, and when multiplying and dividing, there could be some exponents involved. All right, number 2, 1035 divided by, now that is divide. Yeah, even though it looks really similar to multiply, that is divide. Excuse me, to addition, it's divide. So 1035 divided by 42 gives me 24.6428, etc. All right, let's look at sig figs. 4 sig figs here, 2 here. So we need to round this to 2 sig figs. 24 would be my answer. But do you see how 24.6? This 6 is going to round that up. So our final answer is 25. So there is a little bit of rounding involved. Okay, now let's talk units. Meters squared, which is meters times meters, divided by meters. It's just going to be meters. Okay, I'll get this out of the way. All right, our next one is addition, which means we are going to not do total number of sig figs. We're going to do total number of, fewest number of decimal places. So if you look, this has 2 decimal places, this has 1, this has none. So our final answer should not have any decimal places. 12.01 plus 35.2 plus 6 gives me 53.21. I need to round that to no decimal places. Well, this 2 is not going to round the 3 up, so I'm left with 53. Now let's talk units. Since we're adding, it's just milliliters. Do not cube it. Subtraction, again, we're fewest number of decimal places. So this has 2 and this has 1. So we want our final answer to have 1 decimal place. 55.46 minus 28.9 gives me 26.56. So we want 1 decimal place. So you might be tempted to say, oh, it's just 26.5. But be careful. This was 26.56. The 6 rounds this 0.5 to a 0.6. And our units is our grams. Okay? Multiplication, which means we are the fewest number of total sig figs. So this has 2 sig figs, 2 sig figs, 4 sig figs. So we want 2 sig figs. 0.021 times 3.2 times 100.1 gives me a whole bunch of junk. Do you need to see it? I'll give it to you. 6.72672. All right. I want 2 sig figs. 6.7. Does the 2 round the 7 up? No, it doesn't. 7 up. I could go for one right now. Doesn't round it up. Now let's talk about units. Centimeters times centimeters times centimeters is centimeters cubed. We have addition now. So fewest number of decimal places, which is 2, 2, and 3. So we want 2 decimal places. 0.15 plus 1.15 plus 2.051. 3.351 is what your calculator gives you. We want 2 decimal places. This 1 will not round the 5 up. Keep it as 3.35. Centimeters plus centimeters plus centimeters. It's still centimeters. We're not multiplying. This is division. 150 divided by 4 gives me 37.5. However, this has 2 sig figs. This has 1. How do we round 37.5 to 1 sig fig? So the 7 is going to round the 3 up. So it makes it 4. But you just went from having $37.50 in your pocket to having $4. That's not rounding. That's called stealing. So you have to hold the place. You need to put a 0 in the ones place. Now, 37.5 rounding to 40, that sounds like rounding. So that is your answer. Do I put a decimal place here or a 0 here? No, that changes sig figs. So we're going to keep it simply as 40. Now, liters cubed divided by liters gives me liters squared. Okay, subtraction meaning fewest number of decimal places. 505 has 0 decimal places. 450.25, so I have 54.75. But I don't want any decimal places. So I look, this 7 is able to round that 4 up. So it becomes 55. We're not talking about total number of sig figs. We're talking about decimal places. And I know that's confusing. It's super tricky to remember which rule goes with which. You'll get there. Okay, units, kilograms. All right. Number 9, we are multiplying. So it's fewest number of total sig figs, which if you look, it will be 2 sig figs in our final answer. 1.252 times 0.115 times 0.012 gives me 0.00172776, whatever. But I only want 2 sig figs. So here's a common thing that kids do. They just say, oh, it's 0.00, and they call it a day. Wait a second. Don't forget the rules of sig figs. This number has 4 sig figs. These 2 zeros don't count. So you must keep these there to hold the place value. We don't have anything in the tenths. We don't have anything in the hundreds. We start in the thousands. So you're going to look to these numbers. And I want 2 sig figs. Does the 2 round the 7 up? No, it doesn't. So I hold those place values with zeros. 0.0017 millimeters times millimeters times millimeters is millimeters cubed. Hey, since we're about to go into sign notation, how about we put this into sign notation? 1.7 times 10 to the 1, to 3. Now, is it positive 3 or negative 3 exponent? This number is less than 1, so we would have a negative exponent. Both of those answers would be acceptable, and I would, too many M's there. I would accept that, either one. The standard form or sign notation is fine. Okay, last one is in sign notation. We are dividing, excuse me. So we need to have the fewest number of total sig figs. This has 4 sig figs. This has 1, 2, 3, 4, 5 sig figs. Okay, so let's just do some practice with sign notation. This times 10 to the third. So that means move our decimal place 3 spots to the right. 1, 2, 3. Okay, so that means this is 1,278. And this is 1.4267. Move it 2 spots to the right, becomes 142.67. If you are confused as to what I'm doing, which is going from the sign notation to the standard form, please reach out, ask questions, go back to the sign notation notes and videos. Please let me know. Okay, so I didn't change anything to the numbers themselves. I didn't change sig figs. All I did was go from sign notation to the standard form. So now I can divide like normal. 1278 divided by 142.67. And I get 8 point, I don't know why I changed color, sorry. 8.9577, blah, blah, blah. Okay, sig figs. 4 sig figs here, 5 sig figs here. I want 4 sig figs. 1, 2, 3, 4. This 7 was going to round that 7 up. So we're going to have, and I'm sorry that's a mess. This is super messy. 8.958. And this is meters squared divided by meters, which gives you simply meters. Okay? So remember, the whole point, I know you can multiply, divide, add, and subtract. That is really not what we're studying here. What we're trying to do is take that calculation and make it express the accuracy of your measurement tool. Okay, because hopefully anybody can plug things into a calculator, but recognizing our tools and the limitation of those tools is what we're really talking about here. Thanks for watching. If you have any questions, please reach out. Take care.